Hey everyone, I'm Sergio. I'd like to talk to you about Rocket today. So this is Rocket's logo. Hopefully it's pretty. If you write a web framework, you have to make a pretty logo. You have to make a pretty website because you're like a web framework, so you're supposed to be good at the web. If you don't do a good job at that, people won't use your thing. So we made a pretty framework, a pretty logo rather. Hopefully a pretty framework as well. So Rocket is a web framework for this programming language Rust. If you haven't heard of Rust, it's okay. Most people have not heard of Rust, but you should check it out. Rust is a cool language. It's being developed by Mozilla. I won't pitch it to you. Just go to rustlang.org. It's fun. So Rocket is a web framework, kind of like Rails or Django or Sinatra or Flask or anything that you might have heard called a web framework, Laravel, if you like PHP. That ideally makes it pretty easy to write fast web applications without having to worry about how to actually do it, make it do what you want, and also not sacrificing type safety. So Rust is a type-safe language. Think type-safe like Haskell, not type-safe like JavaScript. Actually type-safe. And of course, we're a security workshop, so it's supposed to be, it's supposed to enable you to write something that's pretty secure and not insecure. Rocket is pretty new. This thing actually exists. You can go use it. It's not just a research project. We launched in December 23rd, 4 or 5 months ago. And we got 0.2 out a couple of months after that. And now we're at 1940 GitHub stars. People are actually using this in production, which is wild. People are running this in production. People have switched all of their Node.js development to Rust and Rocket. There are like at least a dozen companies actually using this thing. So you should too, or don't, or just wait a bit. Or decide based on this talk. But this is a thing that people are actually using, and so we hope that it actually makes things more secure, and I'm hoping to convince you that it makes things more secure on the web. So before I tell you what Rocket is trying to fix, prevent, make better, I just want to show you what it looks like. So you have a good idea of what we're going to talk about later on. So you have a good idea of when you're looking at code snippets, what you're actually looking at. So you're about to see some Rust, which is basically C with like the high-level semantics of Ruby or Java or some C++, but it's type-safe, memory-safe. You can't have race conditions, and there is no garbage collector. It's a bit of a unicorn. So this is what it looks like. This is what Rocket looks like. This is Hello World in Rocket. So as you can see, it's pretty simple. There are two parts to this thing. The first is there's a set of matching parameters. That's this thing at the top here. So basically you tell Rocket, I want to take in web requests. And if the web request matches these set of parameters, then this function is the thing I want you to call. So in this case, if there's a get HTTP request to the /world path, then it should call the handler, which is this thing at the bottom, the function. And so pretty simply enough, if you have this code and you were to actually go to the /world route, then you would see hello world in your browser. Pretty straightforward. To actually execute this code, you have to tell Rocket about your handler, so you have to do this thing called mounting. And I won't really get into it, but the essential thing is that you namespace these handlers, these routes on some other path, and Rocket, and you call launch, and then Rocket will actually start a server for you, and it'll tell you nice things about your environment and your world, and it'll go, and you can see that pretty web page. Okay, so that's what Rocket looks like. There's a lot going on. There's a lot of stuff going on to actually make this work, and this in its own is not particularly interesting. We're not doing anything interesting. We're just kind of returning a string. To sort of see why we might need to do something interesting, we have to take a look at why the web is insane. The web is the craziest thing, and it's really hard to get it right. And Rocket is supposed to make it easy to get it right. In fact, it's supposed to make it extremely difficult to get it wrong. In order to do that, I want to see what people have done incorrectly in the past. And I want to look at 3 very popular open source projects. So that's Wordpress. You guys know Wordpress. Spree Commerce, which you might not know. It's a Ruby on Rails application that is an e-commerce site. So this is what Chipotle uses to run their online e-commerce thing. It's used by a bunch of other players. And GitLab is sort of an open source / enterprise version of GitHub. It's a self-hosted version of GitHub. And all of these three applications have had extremely serious vulnerabilities, obviously, as all software has. And Rocket can prevent all of those. So let me walk you through these pretty serious vulnerabilities. And these are just some that I picked out. These are, not only did I just pick out these open source applications, I just literally said popular open source applications, went to CVE and picked the ones that were the most serious. But, and there are many more. There are many more open source projects with bugs. There are many more bugs in these open source projects. And of course, many, many more bugs in closed source projects. So WordPress. So WordPress before 2.8.3 allowed a remote attacker to gain privilege via direct request to 8 different endpoints. And what this means is that you literally sent a web request to an endpoint, and you could ask, hey, WordPress, make me an admin user, and WordPress would return back to you a token that made you an admin user. Nothing special, nothing hard, no trampolining, nothing interesting. You just make a web request, and you are an admin user. This is just abysmal. This is the easiest thing to attack. There's nothing interesting about attacking this. The fix was 8 times of these little fixes. It was to add a check to these endpoints to say, well, should you be able to make this request or not? And so everywhere in the code that you were not supposed to be able to make this request, if this check was not already made, you have to sort of add these checks in to make sure you can't make this request. With Rocket, we'll see that, first of all, getting this wrong in the first place is very difficult. And 2, even if you do get it wrong, you make one line of change and everything gets fixed. Okay, so in Spree Commerce had a similar vulnerability. All you had to do was pass the right parameters via a form, and then you could assign yourself any role. You could literally go to Chipotle's website, change your user profile, send a new parameter, and you were an administrator. You could add a new taco to the menu if you wanted to. And this one is pretty interesting because all of the Ruby on Rails world suffered from this. There was actually a very simple vulnerability that literally every web application probably suffered, and it was just chaos in Ruby on Rails world. And this is partly caused because of the dynamic nature of Ruby, but really it's just the failure to validate inputs. And what it looks like is this top line of code here. So what this does is this assigns the parameter user to a new user that takes in its arguments from the outside world, this params array. And this params comes from a web request. So this is a form that people are filling out. The fix is to remove, in this case, their fix, Spree Commerce's fix, was to remove the user role attribute from that form. And that means that a user can't submit a form, or even if they do submit a form with a user role attribute, that you won't actually use it to create a new user. Now this is sort of obvious. You obviously should be validating that someone isn't trying to set their own user, but this is just, the top line of code is just what you write in Rails. So this is really crazy. A lot of applications are almost certainly still vulnerable to this, and it was a hard day for Rails application developers. So the final one is GitLab here. So GitLab discovered a critical security flaw that allowed anyone to literally click on a button and log in as anyone else. So if you were running a GitLab instance, all you had to do was click on a button or send a web request, and you could log in as anyone else, including administrators, whether or not you're an administrator. So the fix for this is, as you might imagine, is adding a check. So again, this is also another Rails application. So the check looks like this. It's a little small. But the idea is that before you try to impersonate someone, you should check if you're an administrator. Strangely enough, they already had this check, but the check was not a check. The check is if you're not an admin, don't do this. Or if you're not an admin, skip this, rather. So they added a check after that happens, before you do the skip, to quit if you did not skip. It's a very weird thing that they did. So this was the fix. Again, this is something that would just not happen in Rocket. This is not the way you would write web applications. You don't validate, and you'll see in a second, you don't validate after the fact. You can't use anything unless you validate. Okay, so there's a bunch of other vulnerabilities. These are all privilege escalation attacks that I showed you, and these are very serious because that's pretty much all you have. It's like if someone gained root access on your machine, you've lost everything. That's exactly what these attacks are. And these applications, and many, many more applications, are extremely vulnerable to these. And this is the type of thing that Rocket is extremely good at fixing. But there are many, many more things, particular cross-site scripting, directory traversal, cross-site request forgery, code execution, and SQL injection. These are also things that Rocket addresses by design. You just can't do these things because it's not expressible. But these are sort of much less interesting as they've been around for a long time, and they're sort of things that you can fix automatically via templating or via your SQL, ORM, or whatever. So these are much less interesting from a security perspective in terms of fixing, although they're very interesting from a hacker perspective because they happen all the time. Okay, so these are serious problems that we want to fix, and we're going to see how Rocket fixes these things. So all of this bad stuff happens because there's some user, and they're feeding information into our web application, and we're not validating it. So the fix, of course, is to validate this information. That was the fix in all cases. All of these applications added a if condition somewhere or something that checked something before something else executed. So obviously that's what we're going to do, but we're going to do this in a very structured way, a very systematic way. So the first place that we get input from the user is through the path. So if a user visits a certain path, that's input to our application. We respond to which path the user goes to. And in particular, we want to respond to segments in the path. So if you go, for example, /user/ID, we want to do something depending on what the actual value of ID is. So here's an example of that. This is how you would do this in Rocket. So in Rocket, you have these, remember, you have these attributes on your handler. And here we have an attribute /name/age. And you can see name and age are in brackets. And when a parameter is in brackets, it matches any text in that segment. So for instance, if you had /Michael/54, then name would be equal to Michael, age would be equal to 54. But the critical thing is that, well, we want to validate these things. Name should be a string and age should be an integer. Well, the way we do that is we just specify the type. We just say name is a string and age is an integer. And that's it. Rocket will do the validation for you. If name is not a string and age is not an integer, then this thing won't get called. Pretty straightforward. And as a sort of technical side note, anything that implements this trait, it's sort of a type class or an interface, can be included in this as a type here. So that's your own types for your own custom validation. And if the validation fails, then we're going to do something called forwarding the request to the next matching route. And this is where we get a lot of power in Rocket. We'll talk more about forwarding in the next couple of slides. Otherwise, we tell the user that there's no route. There's nothing we can do here. This request did not match anything that we expected. Okay, so this is what it looks like. And the nice thing about Rocket is that it's sort of built on Rust, as I said before, and Rust gives you nice capabilities to actually extend the compiler. And so when you do something wrong, for instance, you declare something in the route that is not actually in the function, then you get really pretty error messages that say, hey, you declared something as an argument, but it's not actually in the function. Please go fix it. And your program does not compile. Rust is a compiled language. Your program just will fail to compile if you don't get this right. Okay. Now, this is pretty simple. A more interesting thing is to sort of prevent directory traversal using this mechanism. So you're taking in a path from the user, and you're trying to serve a static file. Now, you don't want the user to see any files outside of some directory. You want them to only see files, say, in a static directory. And so you have to validate that the path that they pass in doesn't have, like, ... for instance, because if you concatenate some ... they're going to go backwards in the directory tree, and you're going to access, say, etc/shadow, /c shadow. That's really, really bad. And in Rocket, this is sort of straightforward. You just ask for a path. In this case, a path buff, and that's sort of an implementation detail. You just ask for a path buff, and the implementation of path buff, the from param implementation, which is this validation implementation, will check that this is totally valid and nothing can go wrong if you concatenate this. This is one implementation that lives in one place, and you can reuse it anytime you want, whenever you need a path. And then you cannot be vulnerable to directory traversal attacks. It's just that simple. Okay. So this is cool, but there's a lot more stuff that we want to do. This has nothing to do with users and authentication and policies and or anything like that, so we want to take care of this stuff. And to do that, we have to talk about forwarding and its cousin ranking. So forwarding is what happens when you match against the route, but you can't validate the parameters. So it's like if you got an age, but the age is not an integer, then we can't validate that. What Rocket does is it forwards it to the next thing that could possibly match. So here we have these two routes. So we have this ID, and ID needs to be, in this case, an unsigned integer. And if it doesn't match the first route, i.e. ID is not an unsigned integer, Rocket will forward to the next route, to the next matching route. And you see here we have this rank equals 2. So what that says is this is lower ranked. A higher number is a lower rank. And so if anything below me doesn't match, please try me. You can't have things that would match equally have an equal rank. If you do that, your program won't run. Rocket will say, no, I don't know what to do. You're not giving me enough information to make a good decision here. And there's some niceties to make these things sort of easier to work with. But the key here is that things are tried in ascending rack order. So again, what would happen here is Rocket would try the route on the top. It would try to parse the ID as an integer, as an unsigned integer. If that doesn't work, it would try the route at the bottom. In this case, it doesn't try to parse anything because the web is already a string, so we just take it as a string, and that one will always run. So this is useful for giving an error message, for instance, to the user that says, hey, ID needs to be an integer. This is not valid. OK. So now, where things get really interesting and where we get to really prevent a whole bunch of stuff on the web, is this thing called request guards. So a guard is implemented by another trait, another interface called FromRequest. So at a high level, what Rocket is trying to do is ensure that no code executes in your web application unless you've validated everything from the user. You cannot run code on any input from the user unless it has been validated. That is the core premise of Rocket. And that includes validating policies, includes validating simple things like integers, includes validating whether you are authenticated or not. And where we really get to do a lot of this, you've seen a bit of this through, for example, path validation, but where we really get to do a lot of this is via these request guards. So this is what this looks like. All it is you add a new parameter to your handler, your function that's going to execute. In this case, we added this admin user parameter to the function. And this doesn't appear in the route syntax, so at the little decorator thing, it doesn't appear there. And anything that doesn't appear there but does appear in the function signature is implicitly a request guard. And you can have as many of those as you want. And what they do is they validate the world. So this admin user type will get the request from the world, and it will say, yes, this is a valid request. This I can derive myself. I can derive an admin user from the request. Or it will say, no, I can't. Or it will say, maybe someone else can. And if it does not work, if it says, I cannot derive myself, then Rocket prevents that handler from running. And so in this case, this admin panel route will not execute unless the user is an administrator. And now another key here is that in Rocket, there is no global state. You can't just access the request willy-nilly. You have to validate the request in order to access the request. So this means if you want to access anything about a user in this route, then you need a user instance. And the user instance must be validated in order to access it. And so this would prevent things like the WordPress bug. Because in order to do anything as an admin user, which you would need to access the admin panel, then you would need an admin user. In Rocket, you can't get the admin user unless you validate it. OK. And so this gives us sort of authentication. But you might also want policy, i.e. an admin user sees this when they go to the admin panel, a regular user sees that when they go to the admin panel, and then an unlogged in user sees an error message. So if we combine request guards with forwarding, we can actually get this. So guards and forwarding allow you to centralize and encode policy. So at the top there, you see that route that we just showed you. This says you can go to the admin panel if you are an admin user. If this does not work, if this does not validate, then try the next one. You can still go to the admin panel if you are a regular user. So here we might say, hey, you're logged in, but you're not an admin. Please email your system administrator to ask for, I don't know, privileges or something. And then we have a third route that says, yeah, you can still go to the admin route. There's still something that we can match against. Nothing is required to validate this. You don't have a user anymore, so you can't actually leak information here. And you might use this to say, OK, well, sorry, you need to be logged in. Redirect them to log in or something. And so this combination of request guards and forwarding and types and validation allows you to encode arbitrary policy. Again, these types, admin user and user, are user implemented. These aren't things that ship in Rocket. You just implement them and you can do whatever you want. You can do arbitrary validation. Another cool thing, this is sort of a technical detail, but I just think it's really cool, is this thing called managed state. So I said there is no global state, but if you have any non-trivial web application, you're going to need global state. And the way you get this is through this concept called managed state, which is itself a request guard. So managed state looks like this. So assume or say that you have a hit counter on your website. So I said Rust is race-free. So you can't have a global hit counter unless it's atomic or covered by mutex. So here we have to make it atomic, otherwise our program does not compile. And so what you do is you just ask Rocket, you just tell Rocket, hey, please manage this global state for me. Well, really, it's local to the Rocket application. And you do that through this call here. You just say .manage, and you pass in whatever the initial state of the thing is. And then you ask Rocket for the state through a request guard. And again, a request guard is just adding another parameter to your function. So here we say, please give me the hit count, which is state that you're managing of the hit count type. And then you can do, so this is managed by Rocket, and you can retrieve a request guard. And then you can do whatever you want inside of the handler. In this case, we do this atomic operate. Well, this is just relaxed, but we just do an add of 1 to the atomic counter. And then we tell the user that their visit was recorded. So this is sort of just showing the expressibility of request guards. And really, a lot of the power of Rocket comes from request guards. The last thing I want to talk about, 2 more things I want to talk about. But the last in sort of validation that I want to talk about is in parsing data. If you're into the web dev scene, you'll know that Rails had this vulnerability not too long ago where when it parsed JSON, it would allow a user to put Ruby in their JSON and execute it. So I could just send some Ruby to a Rails application, and Rails would just execute it. This is just terrible. I mean, this is bad. So this is a failure of a lot of things. But ideally, we want to parse this stuff. And I don't want to implement my own JSON parser. I just want someone to give me a JSON parser. Hopefully, it's correct. You can't do code execution in Rust, so you're fine. Well, at least not without really trying. But we still want to parse data. Parsing data is obviously something that happens a lot. And this is where we're going to, for instance, fix that mass assignment problem with spree commerce. So say we have some form data. In this case, it's a task. But say it's a user profile, as if we were spree commerce. And all we do is we ask Rocket for the data. So we say data equals this task parameter. And then we just have an argument in our function called task. In this case, we say it's a form. So what that tells Rocket is there's a type called form that implements another interface called FromData. And it's going to parse and validate the body data. And the cool thing is that it's going to validate it against a structure. So think back to C here. So we have this structure task, and it has 2 fields. And what Rocket will do is it will generate a parser for you. This is what that derive from form thing does. It will literally generate a parser for you for the form data that validates and will only emit, because that's the only way it can do it, a task structure if it can parse that from the form. So here, if this was a user structure or something, and we did not have a user role in that structure, then we just couldn't get a user role. That would not be valid input, and Rocket would say, sorry, you can't give me this. This is not OK. And we can do the same thing for JSON. And this time we do this thing called deserialize, because this is sort of a serialization format. And we tell Rocket to only match against JSON and only use this JSON type. So it's really, really simple to change between whatever format that you want. You just change the type and everything just goes. OK, that's enough for validation. Now, the last thing I want to say is how you actually return a response. So far, we've just been talking about getting input from the user. Returning a response should be equally simple. So in order to return a response, you need to implement this other interface called responder. And Rocket implements this for you for a bunch of different types. And if we look at the hello world type, it has a responder called string. And any responder is allowed. String is one responder. You can implement your own. So if you have a custom type, you can implement it. If you have a user type, you can implement it so that it sends out JSON, for instance, if you return it from your function. And that's about it. You can just return a type as long as it implements an interface. Rocket will call that implementation of the interface. Responders can also fail. For instance, if you're trying to serialize JSON, but just given something that is not serializable as JSON, then the responder will fail. In that case, Rocket will automatically call something called an error catcher, which allows you to say, if this fails, please do this. Okay, like I said, Rocket is a real thing, so you can do a whole bunch of stuff with Rocket. If you actually want to use this thing, it's actually usable. There's templates, there are cookies. Everything is streaming, so you can take unlimited uploads as much as your disk can hold. There are configuration environments. You can configure Rocket for development, staging, and production. You can handle query parameters. Again, those are all validated. You can't take query parameters unless you validate them. There's a library for you to be able to test your applications. So this is all supposed to be very, very usable. There are sessions. There's a whole bunch of stuff you can do. Okay, so that's Rocket. Rocket is live at rocket.rs. You can go. There's a guide. There are tutorials. There's documentation. There's news. The code is on GitHub. If you like IRC, you can go on mozilla.org, the IRC on Mozilla. There's a hashtag Rocket channel, and you can come talk to us. Great, thanks, that's Rocket.
Do you support throttling to defend against denial of service attacks?
Sorry, I can hear you one more time. Do I support?
Throttling support?
Throttling. Yes and yes, so in two different ways. So denial of service can happen in two ways. So for instance, you can start a connection, well, many ways. You can start a connection and say nothing. So we're just going to be waiting for data. So yeah, that you just kind of time out. You just time out and have enough resources to handle these. The other denial of service that can happen is someone keeps sending you data. So someone sends you gigabytes and gigabytes and just keeps sending you data. And everything is configurable, but there are maximums for everything. So for example, a form is limited to something like 512K or something by default. You can change that, but it's limited to that. So the answer is yes in different ways.
Great.
Hi.
Question over, anyone over here? Why don't you give them the microphone? Do you have a question? Are you ready there? Go ahead.
I have two questions. One is in validation and other is in responder. When you said validation is must when the user input is requested, the validation what you are validating from the Rocket or the framework, is it like just one validation exists or any based on the type of vulnerability?
Sorry, what was the last part? One validation exists, but?
Just a one validation existing, are you checking that the validation existing or not? Or are you enforcing by the framework that is there any vulnerability type like SQL injection or XSS, that kind of validation you are
both.
ensuring?
Yeah, both of those. So there's input validation. That's where these really nasty bugs happen. And then that sort of trickles down to things like SQL injection. So SQL injection is sort of a failure to sanitize input and also to validate input. We do both, but they happen at different levels. So input validation happens when you get input. SQL injection sort of happens when you insert input into an existing SQL statement. And so we do both with different mechanisms. What I showed was sort of input validation. SQL injection prevention happens by if you insert some input, then we'll sanitize it before we actually use it in a query.
Okay, in responder, do you have any enforcement by the framework that at least output encoding is present, like similar to the validation, what you are ensuring by the framework in the input? Yeah. Are you ensuring similar thing in the responder to encode it?
No, because you can output whatever. Like we don't know what you're going to do. If you have your own transfer encoding, for instance, you can emit that. If you're gzipping stuff, we don't care if you're doing that. So there's no way to really know what you're going to output. That being said, it's very hard to output something wrong because everything is very strictly typed. At the end of the day, you can just emit bytes and you can send that to the user if you're doing like HTTP live streaming or something. But this is like, you're going to implement it, and there's nothing we can really do to tell you that you're doing it right or wrong.
Great. There's a question over here somewhere.
Yeah. So quick question. Great talk. Thank you. One question is, have you thought about applying some of these techniques to like an existing language like Java?
Rust is an existing language. It totally exists.
I guess it's like a really widely used language where you could get like the benefit, right?
Yeah. Yes. So you sort of need a couple properties from the language to get this. And a lot of the fun sort of goes away if your language is too dynamic, because you can't be super strict. For instance, we could do this in JavaScript, but then you can just modify my object whichever way you want. We can do this in Java, but then you're writing Java. So there's a problem there. No, I'm just kidding. Yes, we could apply this to Java. We could apply this to C++. We could apply this to any existing language. It's sort of a concept. We've done it here in Rust because Rust has sort of the right mix of things to make this pretty much fail-proof. You can't really do much in Rust. Rust is very strict in what it allows you to do. Even in a language like Java, you still have dynamism. You can still do fun stuff in Java that is just not valid in Rust. But to answer your question, yes, you can do this in any language. But depending on what the language does and doesn't allow, you might give up more things.
All right, any other questions? All right, why don't we thank the speaker again, and we have about an hour and 20 minutes for lunch.